going to talk about sampling. So let's say we have a population. So here's a population. So let's say I'm doing a survey question, and the survey question is how many teenagers in Ontario have been arrested? My handwriting. You probably don't have to write notes on this. This is more of a watching lesson. You can take notes if you want. So how many teenagers in Ontario have been arrested? Now the population in this case would not be the population of the world. It would not be the population of Canada. It would not even be the population of Ontario. The population in this case would be teenagers in Ontario. So that would be the population. So when we talk about population, we are talking about the population related to the question at hand. If I wanted to know how many seniors dye their hair, then the population might be seniors of the world. Or how many seniors in Canada dye their hair, it might be seniors in Canada. Or it could be the population. If the question is how many Canadians have a job, and I'm including babies, then the population might be everybody in Canada. Now, if I want to know the answer to the question, there's really only one way to get the actual answer to the question, and that is to ask the entire population. And the name for that is call it a census, and I forget how to spell it. Census, that looks right. So, it could be wrong. So a census is when you ask every person in the population the question. So if I want to know how many teenagers in Ontario have been arrested, I might have to ask every single teenager in Ontario. Or if I want to know how many seniors, as I said, dye their hair, I would have to ask again every senior in Canada. And that's usually cost prohibitive and time prohibitive and a little excessive given the question. So what we do instead is we take a sample. And so the sample is chosen from the population, and what we do is we find how the sample answers, and then we hope that the sample answers in the same way that the population would answer. So the sample is essentially a cheaper or a faster way of doing a census. So what we're going to be talking about today are the different types of sampling. And I might talk about good samples and bad samples. And a good sample, so the definition of a good sample would be a sample that gives the same answer as the population. So if the sample gives the same answer as the population, it's a good sample. If it gives a different answer than the population, it's a bad sample. Okay, so I'll kind of list the types of sampling we're going to go through. So there's going to be simple random, systematic, stratified, cluster, multi-stage, voluntary, and convenience. So those are the different types of sampling that we're going to go through. I'm going to go through them one at a time. Random. So let's say I want to know, let's go to that thing, how many teenagers in Ontario, let's go with the seniors. How many seniors in Ontario dye their hair? So if I wanted to pick a simple answer, let's say there's, for example, I'm going to make up a number here. I'm going to say that there's 800,000 seniors in Ontario, however you define seniors. So what we're going to do is we want to know how many of them dye their hair. And we're not going to ask all 800,000 because, of course, that would be a census and that would be cost prohibitive. So a simple random sample, we have to randomly select, let's say my sample size. So we're going to say that the sample size is 200. And I just made up that number. The sample size could be anything you want. Bigger sample sizes obviously are more accurate, but also more expensive to pull off. So in order to get a sample size of 200, you would have to randomly select from 800,000 names. And that's not as easy as it sounds, right? Like, how do you select 800,000 people? So I mean, what you could do is you could kind of, put those names into a hat and mix them up a little bit and pull out a name over here. And there we go. Emily's been one of the, well, she's not a senior, but we randomly pick a name and somebody is going to be selected for, so we're going to pick 200 names and those are people selected. We could do it with a computer possibly. With a computer we have to get all 800,000 names into a system somewhere. And keep in mind that computers are not totally random, but they're pseudo-random, which is probably good enough for these cases. But for most people, a random sample is very difficult to pull off. Number 2. So number 2 would be systematic. So the way I would do a systematic sample is I might, for example, take a phone book and let's say I'm doing a sample on the population of Ontario. I might take a phone book and I might take the third name on the top of every fourth page. So I hold the pages in the phone book and I take the third name and that's the person I call, and then 4 pages later that's the person I call. Or maybe, let's say it's Mayfield and I want to do a systematic sample. So what I do is I have everybody in Mayfield line up on the field and I say I'm going to pick every third person. 1, 2, and these people are going to be the ones that I picked for my sample. Systematic is not as good as a simple random, but it's sometimes easier, right? So, like, imagine if you were lining up in the field, are people lining up randomly? Probably not, right? People are probably going to line up near their friends in some way, or by grade level, or by something like that. But they're not going to be evenly distributed. Just like in a phone book, people in the same family are likely to be clustered together, given how last names work in our society. So there's a certain amount of lack of randomness there as well. But for a lot of intents and purposes, systematic might be almost as good as simple random. 3. Stratified. So stratified, what we're going to do is we're going to divide the population up in a way that matters. So here's our population, right? And we're asking of seniors. So this is Ontario seniors. And we want to know if they dye their hair. And let's say we divide it up into maybe, for example, we could divide it up into male and female. And it's important that when we divide up the population, we have to divide it up in a way that is relevant to the question. So maybe we feel that one gender is more likely to dye their hair than another. So let's say, for example, the population was, of seniors, let's say the population was about 60% female and about 40% male, because men tend to die younger on average. And remember, our sample size we were saying was always 200. So if we wanted to stratify the population according to gender, what we might want to do is say that 60%, of the 200, we would make sure that 120 were female and 80 were male. So then we've stratified it by the population. You can stratify it by a lot of things. You could do it by income. So you might say that, like less than 40,000 to 100,000. Let's say there's income and 100,000 plus, because maybe we think that if you're wealthier, you may dye your hair more or less than the average. And then again, we would figure out what percentage of the population. So let's say 13% of the population makes more of Ontario population being Ontario seniors. If 13% of the population makes more than 100,000, then we would make sure that 13% of the sample was also that, right? So it would be like 26 people who are making more than 100,000, and then divide up the other ones, the same thing. It's important that when you stratify it, it's stratified by something reasonable, right? So let's say let's say we were going to do it by height. So maybe where you have, you know, people who are less than 5 feet, and people between 5 feet and 6 feet, and then more than 6 feet. But, I mean, I guess there could be some gender things working into there, but there's no reason to believe that height has any reflection upon whether or not people will dye their hair. So we might want to, that would not be a reasonable way of stratifying it, right? If I was, let's say the question was, what's your favorite movie of all time? And I stratified it. Let's say we're doing teenagers. So let's say I asked teenagers, I want to know what are teenagers' favorite movie of all time. So it might be reasonable to stratify my sample into grades 9, 10, 11, and 12, because someone in grade 12 might have a different movie preference than someone in grade 9. Right? Back then you were young and foolish, and now presumably you're a bit more mature. It would make less sense to stratify it by the color of shirt worn on June 6th. Right? Because there's no reason to think that people who wear white shirts have a different movie preference than people who wear red shirts, or even stratifying it by hair color. That may not make sense either, right? So, because we don't think that hair color has a relevance to movie preference. It might have something for whether you color your hair, so it might be relevant there, but probably not too relevant on that. That would be stratified. If you're going to do a stratified sample, it's not necessarily that easy. What the pollsters do is they have to get a lot of identifying information. So when you're doing a survey, what they'll often do when they call up people, they'll say, they'll try to figure out your income level and your educational level and anything else that they feel might be relevant to the situation. And that's stratified sampling. So I'll do the other ones on the next video.